Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another edition of Ask an OpenShift Admin Office Hours. We are here, myself, Chris Short, executive producer of this thing we call OpenShift TV. And I am joined by the one and only Andrew Sullivan. Andrew, how are you today?
Wired. I'm ready to go.
Wired, all right.
I've been up since like 6. I've had about a whole pot of coffee at this point.
I'm on pot number 3 because I've been up since 4.
Oof. Yeah.
Yeah.
Well, my wife, she's an exercise instructor, and exercise people are a little crazy. So her first class starts at 4:30 a.m. So she was up at 3:45 this morning.
Lovely.
Yeah, I was not. But yeah, there's some kind of mental thing about like there's a huge difference mentally between 5:59 and earlier and 6 a.m. I don't know what it is, but it's just like, why does 5:59 a.m. feel so much earlier and so much harder to get up than 6 a.m.? I don't know. Anyways,
Yeah.
Yes, thank you, Chris. Appreciate the introduction, and welcome to the Ask an OpenShift Admin Office Hours. So this is episode 31, where we'll be talking about Alert Manager and kind of the entire OpenShift monitoring stack, right? The things that are going on inside of there. So this is one of our office hours series of shows here on OpenShift TV. What that means is that we are here for you, for our audience. And we want you to ask us questions through whatever client you happen to be watching us on, Twitch or YouTube, whether it's the OpenShift or the Red Hat YouTube channel. Feel free to ask us questions in chat at any point in time about whatever topic it is that is top of mind for you. And I see that there's a couple of people chatting already. So
yes.
Please keep that up. And basically what we'll do is we'll answer those questions to the best of our ability. If we can't answer those questions, we will be sure to follow up every week on Friday. I post a follow-up blog post. So we need any follow-up questions or follow-up answers, we can put them in there if I get them in time. And we'll also follow up with the following week stream if we need to. So, and that I also am not afraid to post, retractions, corrections, etc., because Andrew frequently gets things not quite right. How shall we say? So, as I said, today our topic is alerting, monitoring, right? This sort of observability stack. And I am extremely happy to welcome our guest, Brian Gottfried. I hope I didn't ask you beforehand, so I hope that I pronounced that correctly, Brian. So Brian, if you don't mind, please introduce yourself.
Absolutely. And you nailed the name. Well done. Gottfried, but with 2 T's. Yeah. Yes, my name is Brian Gottfried. I've been with Red Hat for about 1.5 years now. I am a DevOps guy in general, pipelines, app development, that sort of thing. But also lately, what I've been working on is a lot of like logging, monitoring, and metering. How do you make sure that when your cluster and applications are up and running, that they're actually staying healthy? So I'm very excited to be able to talk today about Alert Manager, about user workload monitoring, everything for making use of the existing metrics that come shipping with OpenShift, and then sort of expanding that to meet your individual needs. So happy to be here.
Yeah, and this is a topic I'm excited about. And actually, as I said, I've been up for a while this morning. So I've already been doing a lot of research, and what I thought I knew about the OpenShift observability stack, turns out there's been a lot of changes. So I actually, for any Red Hatters watching, I actually did a presentation at Tech Exchange back in 2019, in the before times, around the OpenShift, monitoring stack. And since then, there has been a dramatic change in things. So I know importantly, we want to cover some of the architecture, what it looks like, what are the different components. And then, Brian, I definitely want to see, how all of that comes together to enable user workload monitoring. That was a huge one. I know people were asking about it for a long time. And that was GA in 4.6, if I remember correctly. So it's been there for a little bit. I just haven't had time to circle back around. So Chris, before we get started, I know that I see our Hope 9 has been asking some questions. So
Yes, so our Hope 9 is asking some very future-looking questions, and I will ask them to email me, short@redhat.com, as well as andrew.sullivan@redhat.com. I forget is that accurate? Sorry.
Yep, Andrew.Sullivan, yep.
Yeah, send us an email. We will get you the answers you're looking for, because what you're asking for is very much a product manager kind of question that I don't have the answer to in my head, nor do I know where to go look it up. So I have to ask the PMs. I'm sure Andrew's kind of in the same boat when it comes to service mesh.
Yeah, I don't know the specific Istio version behind the OSSM version without going back and finding the same thing that you would probably look at. I will take this opportunity to plug, when is it, Chris? The 24th is the what's next? Or no, the 24th is the what's new.
The what's new in OpenShift 4.8 is coming on the 24th. It will be live stream here wherever you're watching. Yes.
So yeah, that's one way to find out. So we have two types of presentations when it comes to that. So what's new is what is in the usually the upcoming release. So in this case, 4.8. So you'll see product management present on all of the cool new stuff that's been added. And then we have what's next, which is also product management doing a presentation on what's coming in future versions. And always keep in mind that roadmap things are subject to change and all of that. So sometimes if you were to go back and look at the last what's new and the current what's next, you'll see some mismatches. That's the nature of roadmap, folks. So sorry about that.
Yeah.
But yes, rhope9, please send us an email. We'll follow up on that and get you the answers that you need there.
And just for everybody that was curious, we were discussing future facing things. Don't try that at home on your own cluster.
Or do OKD is
yeah,
bleeding edge, right?
You can do it on an OKD cluster. Just don't do it in prod, and please don't call support if it breaks.
Yeah.
If we're doing it on air here and we say it's a future facing thing, it's not going to work on a current version. Just to let everybody know.
Yeah. So Daniel, I see your question. Any suggestions for long-term storage of Prometheus data? Looking to keep historical data for a prod cluster for a year. So I'll acknowledge that, and we'll push that one off until we let Brian take over, and we'll make sure that we address that in that segment. So please stay tuned while we go through. I'll do in just a moment what I call the top of mind topics. So just things that have happened, things that I think are interesting or useful to you all, our audience, and we'll take just a couple of minutes to go through those before we move on. And then I also see Smitesh.
That the links I dropped or Restream bot spammed are for use, Smitesh, but there's some breakage in the way the links came out, so I'm going to fix that real quick. But basically, to answer your question, how does OpenShift make container orchestration easier than others? What's the key point? The key point is it is a full cloud native experience, OpenShift, whereas some other distros you kind of have to, okay, now I have Kubernetes, what's next, right? We've kind of had an opinionated view using other CNCF landscape type projects to build a full-fleshed cloud native experience on OpenShift is the way I like to describe it.
Yeah, I usually compare it to RHEL, right? Red Hat for 25 years has had this relationship with the Linux community where we work upstream, we do a lot of things upstream, but for our customers, right, the enterprise customers, we bring a lot of additional testing and validation and ultimately all of those things that we do to provide a supported Linux, right? One that we can trust, one that we know, one that you can trust, to Red Hat Enterprise Linux. And OpenShift is the same way, right? We have that same relationship with the upstream Kubernetes, as well as all of the other products that make up OpenShift. So OpenShift at its core is Kubernetes, and then we add that Red Hat supportability work, and then we add on a whole bunch of other things to make it a fully complete, robust, production-ready platform for your containers. So.
Yeah, we want to get you to workloads in production as fast as possible, basically.
Yeah, and I think, and I see Chris linked a bunch of stuff there. At a minimum, just go to OpenShift.com and especially try.openshift.com, and you can get immediately hands-on. You can start checking out what's available with OpenShift.
Try, learn.
Oh yeah,
Restream bot is just gonna spam all this stuff today for some reason. So thank you, Restream bot. Sorry for the repeating messages. That didn't happen an hour ago, but now it's happening now. So there we go.
So a couple of things. So I think, where did this one come from? I think it came from Twitter, Chris. Twitter or email?
Yes, I tagged you in that
Um,
tweet. Yeah.
Yeah, so actually, I think there was two of them. So the first one is disconnected installs.
Mm. Mhm.
So there was somebody who had tweeted at Chris, who looped me into the tweet about disconnected installs are hard, right? They're not fun to manage,
Right.
primarily because of the image content source policies.
Mm.
So ICSP. And what that does for a disconnected install is you say, I'm going to, and you use the oh no, what's the command? It's not Scopio. It's I think it's an OC command now.
Builda? No. OC debug?
No, I
No.
think it's integrated with OC now. It's OC catalog mirror.
Okay, there you go.
So basically, you point it at the source, OpenShift release, which is for better or for worse. Those container images are spread across, I think, 4 different registries. There's Quay, there's registry.redhat.io, there's
Mhm.
catalog.redhat.com. There's like 4 different places that's spread across. It pulls down all of that content and it creates an image content source policy, which maps this source image is now stored in this destination or this new place. So that for the cluster that ICSP is added to, it doesn't know that it's, when you say I need this image, it doesn't know that it's actually coming from somewhere else. It automatically gets remapped to the new location. So I saw that tweet. I reached out to product management. I talked with both the installer PM as well as one of the PMs who works heavily with the disconnected stuff. And effectively, for the answer was, yeah, we know, and we're trying to make it better. So I know that there's some roadmap stuff. Again, pay attention for when the what's new comes along. I know they're doing a lot of work to help make that process much simpler. So one of those things, and let me share my screen here. Are you the Chrome I want? No, you're the Chrome I want. So I'm going to share this.
You're the Chrome I love.
I know. Let's turn on Do Not Disturb so that way I don't get things popping up. So if I go to, and I'm now, what was I going to search for? It is the, I want to search blog.openshift.com or openshift.com/blog.
I think both.
And I want the, it is the update service, I think. So there is a thing, OpenShift update service. So we talked about this back when we did the disconnected install stream. We talked about it briefly back in the 4 or 5 days when this was initially announced. You can see 454. Unfortunately, it is still not GA yet. No. So this is one thing that when it does go GA, this will make that process much easier. Effectively, it connects into Cincinnati. It takes all of the graph data, which is what maps versions, edges to edges, and what's an eligible update and what's not, and all that. So it takes that whole service and brings it offline so that from your deployed OpenShift instance, you point at that update service, and then you get that same, the same over-the-air update experience of just going in and click update with a disconnected cluster that you get with a connected cluster. So that's one thing that will make it easier. But I also know that there is a rather significant effort. I think the slideshow that I had, the proposal was something like 20 slides of here are a number of pain points and here's how we can address those pain points. So I know that they're aware of those pain points, and I know that this process will be getting better over time. I don't know if you shared this link or not, Chris. I'm going to. Oh, you did.
Yeah, I did.
You're on top of things.
I'm on top of things today. I can't find the Rob Zumsky Cincinnati link though. That's what I was looking for.
I've been avoiding that one because we now have an official one.
Oh, we do.
Yeah.
Okay. Good.
On Access.
Okay. I basically need to create a Cincinnati shortcode at this point.
I know. Let me see if I can.
I'm going to the same place. But I have to log in, so you'll probably beat me because you're logging in right now.
Yeah, there is a, it is the OpenShift update. I don't know, we'll start with that and see what happens.
That's going to be a lot of results, dude.
Yeah, it is. Anyways, I'll find it eventually here.
I'm looking. You just keep talking, buddy.
But yeah, there is an actual. Here we go. I gotta find the right. I just got to use the right browser. I've got it in my history.
Oh, there you go.
So we want that guy, and if we post that in here,
that's right. I remember this.
Yeah, so this is the official Red Hat Labs. Those guys created this thing as a part of access.redhat.com, where you can see all of the. Wow, there's a stable 4.8 already.
Mm-hmm.
Where you can see all those edges. So this graph, that data comes from Cincinnati, and that's where it's generated from. So effectively, the update service is what replicates all of that in an offline environment. Anyways, stay tuned. We'll have more information to share on that as time rolls forwards. I expect to revisit Disconnected in the not too distant future. And again, much like the last couple of weeks, if you have topic ideas, suggestions, requests, let me know. I'm doing planning for the next quarter. So anything you are interested in, I'm more than happy to accommodate that. We've got some exciting and interesting shows coming up. We'll share those. We'll add them to the calendar as we know what they are, or as the dates get solidified, I should say. Okay, so that was the first one. And the second one was, so somebody had asked about load balancer options. And this was the other one. I don't know if this came from Twitter or if it came from an internal, or if it came from an email. But it was more or less like, hey, I've got an OpenShift cluster, and OpenShift requires a load balancer. Mm-hmm. So what are the options I need, or what are the options I have for load balancing access to that?
Yeah.
So this is and I'm going to first go to the docs, and I'm going to pick on, we'll go with bare metal. So if we scroll down in the docs, we eventually get down here to, where is it? The load balancer. And you can see that there are two sets of load balancers, the API load balancer and the application ingress load balancer, or star.apps. So this one is api.clustername. This one is star.apps.clustername. So it doesn't have to be two physically or virtually, right, logically separate load balancers. It can be one single instance that you use for both of these functions. That absolutely works just fine. But there's a number of different ways that you can do this. So the first one is not really a load balancer, and that is quite literally round robin DNS. Right? There is nothing that says that it won't work to take a round robin DNS for API.clustername and make sure that it is, the three entries there are your control plane nodes, and same thing for your star.apps, right? Make sure that it is the the infrastructure nodes that have a ingress controller instance. So you will encounter errors with star.apps if you have nodes that don't have an ingress controller as a part of that DNS round robin, because it's not doing any checking, right? It doesn't know whether or not there's something on the other end of that. It just says, hey, go to this host. And if there's no ingress controller, well, it's going to respond back with an error. So you would want to have infrastructure nodes that are hosting those ingress controllers in that instance, so you know where they are. But yeah, it works. It's not a load balancer, but it would work. Keep in mind, Christian, I can't see the chat. Christian's probably giggling if he's listening about using DNS as a quote unquote load balancer. But so the next option, if you are using on-prem IPI, is the integrated, right? And I'm going to use air quotes, load balancer. So we've talked about this a number of times. I won't belabor the points, but effectively this is you assign a virtual IP address, right? So just an IP address that is pointed to the DNS name for star.apps or API. And then Keep Alive D on the cluster manages which node that virtual IP address is hosted on. So this isn't really a load balancer because all of the traffic goes to just one node in the cluster. So the VIP lands on a node that has an ingress controller, so star.apps, and all of the ingress traffic is going through that one node. So if you scale up the ingress controller from 2 to 3 to 5 to 10 nodes, you're adding more instances that are basically available for Keep Alive D to move that VIP to, that virtual IP address to. It doesn't direct traffic to those. So with UPI, and in some scenarios, and we've talked about that before, I'll try and dig up the appropriate episodes. You want to use an external load balancer, and of course, with non-integrated, it's required. So that external load balancer can really be anything that you want or that you are comfortable with, right? That is capable of providing the services that you need. So what do I mean by that? Usually there are two big things that you need to take into account with a load balancer. So the first one is, of course, literally throughput, right? My applications need 74 terabits of throughput, right? To be able to access whatever they're doing. Okay, well, that means that you need to choose a load balancer that's capable of doing that, or load balancer farm, or whatever it happens to be. I hope it's a farm at that time. Yeah. The second one is high availability. So there are a number of options out there. Certainly partners like F5, Citrix, Nginx, etc., are all possibilities.
Yeah.
Red Hat, a lot of us, on the Red Hat side, will deploy HA proxy to like a RHEL VM and just use that. You can make that highly available by deploying 2 of those and using Keep Alive D, so that you have that virtual IP address between the 2 load balancers. So that is certainly an option. Whether or not it's production ready entirely depends on your needs, what it is that you are trying to do, so on and so forth. So I'll also offer that it can be a little bit confusing sometimes with our partners. So if I go to, I'm going to pick on F5 here. If I go to catalog.redhat.com, and if I go to software and OpenShift operators, and then I search for F5. So we have this F5 operator inside of here, right? And when I deploy this, what's going to happen is I'm going to deploy a new ingress controller. That is the F5 ingress controller. And it integrates directly with, and you see there, F5 big IP. So that when I create a new ingress that is using the F5 ingress controller, it's reaching up and it's talking to their physical or virtual big IP device and doing configuration at that level. This is not the same as if I were to configure an F5 load balancer to point to the default HA proxy based OpenShift ingress controller.
Right.
So just, it
There
can
is
be a little bit
distinction,
confusing. Yeah.
Slight distinction, but yeah, it's instead of pointing it at that, catch-all kind of DNS entry, you are using the F5 to point it directly at your app's ingress.
Yep. And there's positives and negatives to both of those, right?
Mhm.
If you are, and Citrix works the same way, Nginx works the same way, right? There's a number, these are just the certified ones. So that's the ones I tend to talk about. There's others out there that absolutely can work. But just work with whoever your vendor is to understand if they have a Kubernetes ingress controller, whether or not that works with OpenShift, and whether or not you want to use their ingress controller, or if you just want to use their load balancer and the default OpenShift ingress controller. And I'm sure somebody is probably thinking, hey, well, why would I choose their ingress controller over the OpenShift one? I leave that to the vendor, right? So if you're talking to F5's up on the page here, if you're talking to F5, they're the best ones to ask, why is your ingress controller better than what OpenShift provides?
Mhm.
And there's nothing wrong with that. Okay, and the last one I had, so this is something that comes up, I won't say regularly, but not infrequently, and that is the time zone settings for the cluster. So I'm going to go back to the docs.
To the docs.
And I want post install and machine config and configuring the Crony time service. So one of the things that you should do with your cluster, of course, is ensure that time synchronization is configured.
Yes.
Right? It has to be within a certain window for the cluster to be able to successfully deploy, right? Certificate times have to match and all
Certificates matter when it comes to time. Time matters to certificates.
Exactly. And you don't want it to drift for a number of different reasons, not the least of which is, in line with today's topic, being able to do things like troubleshoot and logging, correlation and all that other stuff. Time is important. So you definitely want to go in and you want to configure Crony to synchronize. But we've had a number of folks ask, I don't like, right, I live in Eastern time or Pacific time or whatever time zone, and everything in my organization is on that time zone. But the OpenShift logs are in UTC. Can I configure the time zone?
Right.
So unfortunately, not yet. So there is an RFE for that. There's actually 2 of them. So they are, I know that they're looking into how to do that, et cetera. I don't have a time frame. I'll dig up the RFE so that way you all can look at it.
Yeah, like by default, the Kubernetes that comes from upstream Kubernetes on GitHub uses UTC, and that's it, right? Like there's no options to change time zone, to my knowledge. So that's where it comes from, is the original Kubernetes project, if you're curious.
Yeah, and I know a lot of, like, I think Splunk offers the ability to localize dynamically and stuff like that. I don't know if the Elasticsearch service, a logging service in OpenShift does or not.
I feel like you could configure that, but we have an expert here.
Yeah. Well, we're not talking about logging necessarily today.
Right. Yeah.
Although it is a part of the overall observability story. But yeah, so just be aware. Unfortunately, today you cannot, and I'll take when I shut my mouth here in a moment, I'll take a moment, see if I can figure or find the RFE. I'll post that into the chat if you want to take a look at it. Hopefully it's a public one. But yeah, it's not there yet. It is something we are aware of, but definitely ensure you configure the time synchronization at a minimum for a number of different reasons. Okay, that's all I got. I'm done with the top of mind stuff. So let's move on to today's topic. So Chris, I haven't been paying attention to chat really. I don't know if we have any.
Quiet.
Okay. So just a reminder for any of y'all who are listening to us, please feel free any point in time, ask us questions, and we'll address those as they come up. So TZ data file for Detroit. I know.
I love it. It's great. It really tells you the history of time, right?
Yeah.
Like,
well, now wasn't somebody saying that now there has to be one for Mars because there's going to be computers that are.
There's already computers on Mars.
Yeah.
So they measure it in sols. I know NASA does, but I'm not sure how it would be fun to get NASA on to figure out, like, how are you doing time zone stuff?
Yeah. Like, isn't I know there's OpenShift in space. Like,
yeah.
What time zone do they use?
UTC probably, because everything is done by Zulu time, which is
not Houston,
not Houston time. No, they use UTC too.
All right. So Brian, OpenShift monitoring, OpenShift alerting. So one of the first things that I know I had brought up is I think it would be good to do an overview and to look at kind of what's the architecture and what does it look like today when we are deploying and using the OpenShift monitoring stack. So you notice I conveniently had this link already up. So I'm going to post that one into the chat here. And what I really wanted to concentrate on here is this diagram here, which can be a little intimidating, not the least of which because there's a lot of interesting words here. We see this Thanos query here in the middle, right? Most people think Thanos, and of course they think the big purple guy with the, with the wrinkly chin. They don't think of an alerting or a monitoring set of tools. So the first thing that I wanted to talk about is what are the components of the OpenShift monitoring stack? Brian, if you want to describe those, and I'll you can take over the screen, or I'll bring up some of those components as you're talking about them.
Yeah, no, I think this diagram's a great starting point, and feel free to keep driving the screen share for it. So essentially, you've got something that actually gathers data, right? Because you need to be getting data from everything that's running on OpenShift in order to be able to do anything with that data. And that's the Prometheus instances, both the platform one and when you set up user workload monitoring, the user workload Prometheus. Then you need something to be able to view those, and that is Grafana for the platform one. And then you need something to be able to tell you when specific things are happening, because there's so much data coming into both of these Prometheus instances. Trying to monitor everything via a Grafana dashboard it's going to be trouble. Like, you need to know when specific things happen that are critical to the health of your cluster, and that's where Alert Manager and the Thanos ruler come in. So it's really this idea of gather the data and then to do things with the data, you either want to be able to view it at a high glance and over time, and that's through Grafana, or you want to get quick, oh no, something's gone wrong alerts, and that's where Alert Manager and the Thanos ruler come in. So all of those components are sort of integrated in. Prometheus and Alert Manager and Grafana are the sort of traditional stack. They've shipped with OpenShift for a while. The introduction of these Thanos components has been a little bit more recent in the later half of the 4 versions of OpenShift. Thanos is I want to say like a sister or a compatibility project with Prometheus. It implements a lot of the same Prometheus APIs, but it has a lot of functionality on top of it that's designed for distributed large scale systems. And I know there was a question earlier about long-term storage. That's one of the things that Thanos does. I think that when we dive into it a little bit more, we can talk about the different components of it. Really what the Thanos Querier is doing in this specific case is it's acting as a central point for any of those components that need to go back and access data, whether it's data that's shipping in from the cluster Prometheus or data that's being gathered by the user workload Prometheus. The Querier acts as a central point to be able to query that data. And we don't have it right now, but if you were to also deploy some of the Thanos backend stuff, like long-term storage, the Querier allows you to pull data from both in-memory storage, persistent storage within the cluster, and that long-term storage kind of simultaneously and seamlessly. So you can get a query across a real long scale of data without having to do any sort of like stitching or combining across multiple queries. So it's, as you mentioned, the diagram is large and complex, but thankfully most of it really works behind the scenes for you. When you're looking at a cluster, you're going to be querying stuff via Prometheus, running PromQL queries to get sort of ad hoc stuff. You can then take more complex queries or queries that you know you're going to be looking at a lot, and you can make them into Grafana dashboards. And then you're also going to use those queries to say, I know the situation that I'm concerned about with the health of my cluster. I can represent that by monitoring this specific Prometheus metric, and when it reaches this threshold, or when this metric changes from 0 to 1, or when it drops below a certain number, I want to get an alert about that. And that's how you end up setting up alerts for Alert Manager, or really when you're setting up your own alerts, to set them up to go through the Thanos ruler. You're still using PromQL to do it underneath the hood. It's sending you out an alert that's more descriptive rather than showing you a graph that has a sudden drop or a sudden spike or something like that.
Yeah. And so if we look at this diagram, we see a couple of things. And as with most things OpenShift related, it starts with the Prometheus operator. So I'm going to switch over to my cluster here. And what I want to look at is, I'm going to go to projects. I'm going to go to monitoring. So we have 2 projects that are inside of here: OpenShift monitoring, OpenShift user workload monitoring. So this block here, which is the OpenShift monitoring components, this is for monitoring all of the core OpenShift things, right? Basically anything in a namespace that starts with OpenShift. This is always installed, and you can't really mess with it, right? We don't support modifying the things that are going on inside of there. So if we look at this particular namespace, and I go to, it's not operators, I want pods. We see a number of different things inside of here. Let's get that out of the way so it's a little easier to read. So here's all of our alert manager pods, right? We've got our node exporters. This is just a simple machine set that goes, right, deploys all of those Prometheus exporters to each one of the nodes, the Prometheus pods, so on and so forth. And here's our Thanos Querier. So it deploys all of these components into that namespace and across all of the nodes. And then Prometheus pulls in those metrics from the node exporters and stores them. So Prometheus operator deploys Prometheus, it deploys Alert Manager. Prometheus, and I think this is something that's, I always forget this and I don't know why, but Prometheus is where you actually configure the alerts. Alert Manager is only responsible for telling you about them.
Yep. So Alert Manager handles how often alerts are fired, where you're actually sending them to if they're going outside of Alert Manager, when you repeat them, whether you send resolved solutions for them, sort of managing how multiple alerts are firing. So there's the possibility to, if you know there's some alert that says like the entire cluster is down, you probably don't want to be firing the 15 other alerts that are saying these individual components are also down, right? So you have the ability to set up a hierarchy of rules so that if a certain alert fires, you're not getting bombarded with a bunch of other alerts that aren't relevant at the time. It offers a lot of control over the alerts that come out of Prometheus. Prometheus, you're kind of defining alerts on an individual level, and they're relatively sandboxed within each alert. Alert Manager lets you control the relationship between them.
Makes sense. And that brings up one of my, I won't say favorite topics, but something I try to remind people of regularly, which is alert fatigue is a thing.
Yes. And you can build bad patterns through alert fatigue as well that will make you ignore good alerts.
Yeah. How many times have we, on some random website, you get this pop-up and it's just the same as 500 others, and you just click it away and it's, wait, that one was important. What did that say?
What did that say? Yeah.
Yeah. Alerts are the same way. If you've got a bunch of noisy alerts that don't mean anything, it increases the likelihood that you're going to miss something that is important. I should also point out, I didn't start at the beginning when I was talking about the operators. I started with Prometheus, but actually it's the cluster monitoring operator is kind of the first. So it's responsible, you can see here, for deploying the telemeter client, the Thanos courier, as well as the Prometheus side of things. And then Prometheus goes and deploys Alert Manager. So that's the hierarchy of things there. Okay, so inside of my namespace here, right, I've got all of the pods, all of the things that are relevant to doing the core OpenShift monitoring process. And when I want to turn on the user workload monitoring, I have to go and basically tell it, hey, we want to do user workload monitoring. So if I do the same thing, if I look in the user workload monitoring, all I did here was edit, and then let me see if I can. So it's a config map.
Yeah, it's a config map actually back inside OpenShift monitoring.
Yep.
There it is.
Then we'll go here, and then I want config maps, and it is
the cluster monitoring config.
Thank you.
Yep.
So if we look at this guy, very, very simple. Literally, all the data is enable user workload is true. In typical fashion, the operator then takes action and it deploys all of those components or redeploys them as necessary for doing user workload monitoring. So come back up to our projects. We'll go to monitoring. So by default, without that configured, this would be an empty namespace. Yep. Let's look at pods. But since we enable that, we now have this second Prometheus instance that is now running. And we also have the Thanos ruler, which is rules for collecting information, I think, along with.
Kind of serves as the same thing as Alert Manager. Functions the same way. So it'll handle rules, any alerting rules you set up for the new monitoring that you set up via user workload. The Thanos ruler receives those alerts and handles sending them out to various places. So it gets a same style of configuration, but it's just a different component for it. And then everything still does get routed back to the original Alert Manager.
Got it. And so I want to take a moment to talk about Thanos in a little bit more detail, and in particular, why and where Thanos is important. So Prometheus is really good at what it does: scraping metrics, aggregating them, being able to display back all of those charts, graphs, right? All of the data that's there, although there's arguably better tools for displaying back the data, but it provides that, right? PromQL. The query language to get all of that data out. But Prometheus is not good at multi-instance, right? Of aggregating across multiple instances, of long-term data retention, right? There's no concept of, and I'm probably going to use the wrong term here, but it's effectively summarization of stats. So years ago, it's still around, right? The RRD tool, right? For storing and generating graphs of data.
Yeah.
And you have a short window of very fine-grained data that eats up a lot of space. And then those get summarized into, so maybe you collect those every 15 seconds. And then those get summarized into every 5 minutes. And then those get summarized into every 60 minutes. And then those get summarized into every day, and so on and so forth. And as you go down in, down in granularity, it effectively consumes less space with slightly less detail, right? As the case may be. So Prometheus is not necessarily great at that. It's not one of its things. So Thanos is really good for multi-instance, right? As you can see here, we're aggregating across the two instances. I'm pointing at the screen like you all can see me. So, we're aggregating across in this case, the two instances, as well as it has the ability, and Brian, I'm going to hand off to you, right, to talk about its ability to offload those longer term metrics and data.
Yeah. So actually, I think, do you have the Thanos IO page up right now? Yeah. So if you want to go to that, and then I think if you scroll down a little bit and we look for the components, Thanos has long-term storage components. It's really it's a combination of several. Try the docs, and then let's see here.
Design?
Yeah, maybe inside the design. Okay, yeah. So it's a combination of a bunch of different possible components, and one of those is the Thanos storage thing. So what it does is it takes the time series database data that is being stored either directly in memory by a Prometheus or a Thanos instance, or in persistent storage. And every so often it grabs that, and like you were mentioning, it goes and it downsamples it. So it takes it from the exact time frame it was in, it downsamples it. I think the defaults might be 60 seconds, 5 minutes, and an hour. And it has different scales at which it downsamples. And you can configure at what time frame, how old or how stale does that data need to be before it starts downsampling, so you can make sure you have the appropriate granularity. But it does that automatically and compacts it down. And then you can push it off to the Thanos store, which is an object storage, anything S3 compatible. And it'll store it into there. And then your Thanos receiver can sit in front of both that Thanos store and the object store, as well as your in-memory data that's inside the receiver itself. Your query, can sit in front of both of those and query across them at the same time. So you can query for some metric over the course of a year and a half, and it'll pull up all of the year and a half data from the object store. And let's say your in-memory storage is 4 days. It'll also pull up the last 4 days directly from Prometheus itself, or the Thanos receiver, depending on what's behind it, and display those as a single continuous graph or a set of table data. So being able to compact down like that, somebody asked earlier, how do you handle the vast amount of data you're getting, especially with the Prometheus that ships with OpenShift by default, because we have a ton of metrics that ship with it, which is great, but it also means it's a ton of storage if you're trying to store over a long period. Integrating Thanos into that and being able to push off some of that longer term storage to it, where it starts to compact it down. Object storage in and of itself is just a lot cheaper than persistent storage and storing that way, but the compaction really gives you that multiplier effect and being able to store for long periods, really indefinitely, possibly. So it's very powerful in that way. And then with, like you mentioned, that multi-tenancy aspect of it, it makes it a lot easier to seamlessly support all of those and give whoever is querying that data a single point of entry for still getting back to it. They don't need to worry about, I need data from the last 6 months, so I need to go and query the object store using this Thanos instance instead. You just hit your querier and it seamlessly covers data coming from everywhere at the same time and stitches it all together.
So I don't want to put you on the spot. I want to spend about 2 minutes talking about Grafana and Observatorium. And then if you have I want to address Daniel's question. If you have like an example that you can show of how to configure that longer term retention, and whether that's you want me to drive and show, or if you have something that you can share, either way. And then I think there was another question down here. rhope9 asked if you have an example of alerting with Mattermost, or at least we can point to an example maybe. And then let's see, EXERR.
There is a question about monitoring of service mesh.
Okay.
With MTLS. So yeah.
Okay. So I'm going to talk just real briefly about Grafana and Observatorium. So Brian, if you need to stage anything, I'll give you that time. So I do want to quickly highlight, if you've been using OpenShift for any period of time, when you look at the dashboards in the recent couple of versions, these have changed. Right? It used to be that this would link directly out to Grafana, which we have here. And you would be able to see all of the dashboards as soon as I move this out of my way. And I can go in here and I can look and I can see all of the things that are happening in my cluster right through Grafana. And my understanding is that we are moving away from this being the primary interface for reviewing metrics, with the primary reason being RBAC. Effectively, we don't have, or Grafana does not have a way, and I may be misunderstanding the way that it was explained to me, but it's hard to do RBAC that is integrated with OpenShift and namespaces and only allowing specific people to see their specific things, like it is, or unlike it is with when it's natively integrated into the dashboards. So I can come here to the etcd dashboard, and you see I get very much the same information. So for all of those default dashboards that we ship, that Red Hat ships with OpenShift, effectively expect this interface through the OpenShift UI to become the primary interface for that. But you'll still be able to, and this Grafana instance is read-only as far as I know. Right? We don't support adding custom dashboards or anything like that. You can still deploy a Grafana instance and create all of your custom dashboards and all that other stuff, just like you've always been able to if you so choose in the future. But yeah, just FYI, this is going to be the primary interface in the future.
Mm-hmm.
So the other thing I wanted to talk about quickly, which was one that I was chatting with one of the engineers. I didn't actually know about this, and that's Observatorium.
Yeah, no, this is a new one on me too.
Yeah, so Observatorium, which I understand they're trying to bring under as a CNCF project.
Mm-hmm.
So this is effectively an aggregator for an aggregator, if we think about it in a certain way, right? So
Mm-hmm.
essentially it is a long-term repository for, and you can see here, allows you to manage, integrate, and combine multiple existing projects like Thanos, Loki, so on and so forth. Lots of Avengers references there. So Observatorium is a massive data store and database for all of that metrics data that allows that aggregation to happen. And from what I understand, Red Hat uses this extensively with the managed services. So if you're using, OpenShift Direct or ROSA, right? Red Hat, OpenShift, AWS on AWS, ARO, Azure Red Hat OpenShift, right? ROCs, the IBM offering, right? Basically all of those feed data into an Observatorium instance that is run by Red Hat. And that is how we provide those long-term analytics and other information out of that. So I don't have a lot more information on that. This is one that like I said, I just learned about it. So I'm interested in learning more. Maybe we can get some of the folks there. And I think, Brian, you said that it was ACM can also use this?
Yes, that's actually how ACM manages its multi-cluster metrics. It deploys the Observatorium operator, and then the operator goes and sets up a Thanos instance with all the necessary components. That actually ties into, I think there was a question around seeing an example of setting up a Thanos store. That is, I think, probably the greatest weakness of Thanos right now is that it's relatively new and it's relatively complex.
Yeah.
So I don't trust myself to try and set that up in a short time frame there. I'm sure we'd have a lot of speed bumps. The Observatorium API is a great starting point for that. Or if people don't mind me plugging for ACM, I've been working with it recently with one of my clients. It really makes it incredibly simple to get multi-cluster observability set up, but also get that long-term storage set up. I think there would probably be some growing pains with getting Thanos set up within a single cluster's Prometheus. So if you're trying to work out long-term storage, you're already operating multiple clusters. It may be, from a time perspective, it may be easiest to look into ACM because it's really going to help abstract away a lot of the setup requirements for getting multi-cluster observability set up, as well as getting the long-term storage that you might need. Certainly, if you only really have one or two clusters and you just want to be able to set up a Thanos instance for that, it may be worth the time to do it individually. But you are going to find that there's going to be probably a lack of examples out there so far. Thanos is still a pretty new project and it's still growing and evolving. So I personally I love having the BU developing behind me and supporting me in that way. But whatever floats your boat at the end of it.
It's always nice. Yeah.
All right. So Brian, do you want to share?
Yeah, I can go ahead and share.
Okay.
So yes,
Quick time check. We got 10 minutes left.
Yeah.
Okay.
Right,
So
let's dive in a little bit.
And a reminder for our audience, please submit any questions that you have. So I see, while you're shifting stuff around, Brian. So I see a couple of things in here. So RHope 9, yeah, I know Grafana has RBAC. So
That's the fancy part.
I need to find some details. I'll see if I can find details and include them in the blog post, or maybe we'll talk about it next week as to the precise rationale there. I know it's changing, so Let's see, and I want to talk about EXERR. Is user workload monitoring with Istio injected apps going to be supported with, I don't know what MTLS is.
Mutual TLS.
Okay. At the moment, there seems to be no way to scrape metrics on service mesh with MTLS enabled. The only solution we've seen is probably federation. Brian, unless you know the answer to that, that's not one I'm familiar
So
with.
I haven't done much with Istio. I don't know whether the limitation there is something to do with the MTLS portion of it, or if it's something about where service mesh is being deployed. I do know that user workload monitoring right now doesn't let you create alerts inside any of the default OpenShift namespaces, and I'm guessing that Istio is being deployed inside something like OpenShift service mesh, and that may be the limitation there. And that's kind of just, you get two different teams working on different priorities, so you got to get the communication port in there. And RFE may be the best option. My only concern with federated Prometheus is I know that performance is a real big issue. That's kind of the main reason they created Thanos in the first place, is trying to set up a Prometheus that scrapes from other Prometheuses, because it's a pull method as opposed to a push. As you get more data into there, it's really difficult to scale that top level Prometheus so that it can actually handle it in memory. So you can certainly give it a shot. I personally haven't had a lot of success with trying to do a production ready federated Prometheus. It requires a lot of tweaking and very careful measuring of what you think your load is going to be to ensure that you don't get kind of a cascading crash effect. So I'm sorry I don't have a better answer in regards to that. That is a complex situation, I think. Maybe go back to your service point for it and see. You may be ahead of the pack and you may be the one opening up the RFE. Otherwise, there may be somebody who's already sort of noticed that some of these components may need extra measuring, but don't have the ability to do so yet.
And I'll ask around on the BU side as well, see if we can find from product management or engineering any additional information. So a question from, I think that's going to be Poacher. Is there a way to get container metrics from a pod with multiple containers?
So that's a good question. I think what you could do is, so you're setting your pod up, you have multiple containers in there. You could have each one of them pushing out metrics on a different endpoint, and then set up a service monitor for each port essentially on that pod. And that way you can measure from multiple ones that way. I haven't actually tried that before. Usually I try to, as much as possible, stick with the sort of one pod, one behavior type thing. So I don't normally have a need to measure metrics from multiple containers within a pod. Usually, if I've got a pod with multiple containers in there, you have kind of one main container and then some supporting ones in there that their behavior usually stays internal. So I think it would be possible, but I haven't tried it personally, so I don't want to commit to that necessarily. But my guess would be try and expose multiple ports on that pod and have the containers output their metrics to each one of those ports individually. And then you would set up a service monitor or pod monitor to measure each one of those separately. And then you'd actually be able to capture the instances that way. So I think I threw a bunch of terms out there that we maybe didn't cover, but within the documentation for managing metrics inside the OpenShift one. So there's a thing for setting up metrics for user-defined projects. And that's where service monitors and pod monitors come in. Really what they're doing is you're just pointing user workload monitoring to a specific service. In this case, like we can look at the service for this example app they have up here. They're setting it up on port 8080. Then you set up a service monitor, and all it does is says for that same application label, go and grab the metrics that are being exposed on this specific port. So if you defined multiple ports within your service or within your application, if you're doing a pod monitor instead, and you have each one of the containers pushing out on a different port, I think you should be able to then set up a service monitor for each port that's being output there. Label would be the same, but obviously your port name would be different. And then you should be able to capture from multiple ones. Hopefully that helps.
And then Daniel also has another question. So I want to, we've got about 5 minutes left, and I think we do have a hard stop at noon today, right?
Yes.
I think Turbonomic is on at noon.
Yes. A new IBM acquisition, Turbonomic.
So I want to make sure that we don't have to do an abrupt close. So there's 3 questions that I'm aware of. So one is the configuring long-term storage. So I'll be sure to include that in the blog post. We'll also briefly talk about it next week, Daniel, if you're able to tune in. So for the Mattermost example, I will dig up where that's at.
There is one out there.
And
I just don't know.
I'll
where.
put that in the blog post as well as we can talk about that next week. So Brian, maybe you might be back on a little bit.
Sounds good.
Awesome.
And then and then Daniel, can alert managers send alerts to separate email addresses based on namespace labels in which the alert occurs?
That's a good question. I think it's going to depend on how you define your alert. You can definitely apply individual labels. Well, actually, so any alert that comes out of Alert Manager is going to come with a namespace, I think, included on it already. And then within your alert configuration, do I have an example? Let's see here of, here we go. So this is an example alert. This is actually sort of related to the Mattermost one. Or no, hold on. I don't have the alert in question. But at any rate, there is a possibility to sort of set up dynamic endpoints for alerts within your Alert Manager configuration. So within this router here, you can see for routing to a Slack channel in this case, setting up the receiver, it has this webhook URL here. You could set it up to pull from a label there. I think there's another robust perception one about, and by the way, this is an incredible resource if you're trying to figure out a specific use case for Alert Manager or Prometheus. Robust Perception is a great blog for that. And then actually, here we go, using labels to direct email notifications. So we can link this. I can send this blog post to you guys and have you push it out via there, via the chat, as well as later on in the blog post. Sent that via Google Chat. But you can see here, you can pull out labels from a alert that is reaching Alert Manager, and then specify that in the receiver configuration. So you would probably want to do the same sort of thing here. And then I think it would just be .labels and then namespace. I'd have to go and look and see where the namespace label actually comes up, whether it's in the group labels or in the individual alert one. But you should be able to do the same sort of thing as this in order to specify them in there. The only thing that might be difficult is that if you're not mapping the field of the namespace label directly to the email that it's sending, you might need to do some sort of translation inside this receiver, right? So you'd say for namespace NS1, I need you to send to email this. For namespace NS2, I need you to send to email this. You might have to do that logic inside the receiver here. Or if you can name your namespaces based on whatever the email is, that would also, or vice versa, if you set up an email account that is named for the namespace, then you don't need to do any sort of that translation. You can just directly put the value of the namespace label into the to field right there and send it that way. So it's possible, depending on whether you're trying to use pre-existing emails and pre-existing namespaces and those values don't match up, you might need to do a more complex receiver logic, but it is definitely feasible.
All right. 1 minute warning, or 45 seconds as it were.
Yeah. All right. So I know that we had some outstanding questions that we didn't get to. If you saw me looking down, I was taking notes on what to follow up on. So like I said, I will follow up in the blog post on Friday. We'll also follow up in the opening segment of the show next week, which, as I understand, Chris, you will not be with us next week.
I will not be here next week. Langdon will be filling the role of Chris Short.
Yep. Next week. So thank you, everyone. Thank you, especially Brian. I really appreciate you joining. You've been tremendously helpful, and I have learned a huge amount in this particular episode, more than usual. So yeah, it's as I like to say, OpenShift is like a fractal, right? Every time you learn something, it turns into a whole bunch of other things. That every time you learn something about one of those, it turns into a whole bunch of new things. So if you have any other questions, any other things that you would like to see covered or have us address, please reach out, andrew.sullivan@redhat.com, or Practical Andrew, as it is in my Twitch username here. On Twitter, you're welcome to reach out to me at any time. I'll throw Chris under the bus as well, short@redhat.com. And aside from that, thank you so much, everybody, for joining us today. And please stay tuned to learn more about Turbonomic.
Yes, thank you. I'll be switching over right now. Thank you for tuning in, everyone.